Hello, today we're going to talk about a concept of a straight line. We're going to talk about straight line on a plane and a straight line on a sphere. Back in old days, before 600 BC, people used to think that Earth was flat. If we make that basic assumption and we think about distances people traveled from point A to say point B, we can talk about different paths that one can take between those 2 points. If I want to travel from this point to this point, can I take this path? Sure, why not? How about a path like this? Any of these paths would work. How many different paths, in fact, I can take? There are infinite number of ways I can travel from point A to point B. But are these the most efficient path one can take? Is there a new way I can travel from point A to point B faster? Well, the shortest distance between point A and point B would look something like this. So I have a string here, and it's taut between these 2 points. Here we go. So this path that we're creating here will be the shortest path between point A and B. Let's see if I can sketch it. In fact, when we talk about straight lines on a plane, we're actually discussing this concept, the concept of the shortest distance between A and B. This line segment, if continued in both directions infinitely, is going to create a new geometric shape, which is a straight line on a plane. So when I think about straight line on a plane, I'm considering the shortest distance between point A and B, which is this straight line segment, and continuing straight line in both directions create our new geometric shape, a straight line on a plane. Let's say I'm a superwoman or a superman, and I'm traveling in the same direction. If I choose to start traveling from point A and I travel north without changing direction, the path that I will create from point A will be a straight line. So here we are at point A, and we continuously travel north. The path created will be a straight line. Now, just like a superwoman or superman was traveling north on a flat surface, now we're going to demonstrate what happens if I have a drop of ink and it's traveling straight south. So here is some ink I have here, and if I put a drop of ink on a white flat piece of paper, the path that is created by an ink drop on a flat surface will be a straight line. Another way to create a straight line is to take a flat paper and fold it. The geometric object, geometric shape created in a fold at the meeting place of 2 planes is going to be a straight line, as you can see. Remember Superwoman and Superman traveling between points A and B? They used to think they're traveling on a flat surface of the Earth. Now in modern days they realize they're traveling on a sphere. What is the path between point A and point B on a sphere? What's the most efficient way to travel between those 2 points? Is that going to create a straight path? If a superwoman or superman are traveling from point A to point B on a sphere, they can take infinite number of different paths between these points, but most efficient, the shortest one, will be a straight path. So if we're traveling between those 2 points, and here's a string too that I can use, here's a taut string between point A and B, this path over here is an arc of a great circle. And a great circle is the circle on a sphere that is equivalent of a straight line on a plane. The reason we call it a great circle because it has the largest possible radius on a sphere. If we start traveling from South Pole north, without changing direction, continuously straight, what's the path we're going to create? Imagine going directly north the entire time. What you're going to notice that you'll end up in the North Pole. And if you continue that path even further, you'll create a great circle on a sphere. Same idea would work if I start somewhere in the equator and I continually travel east or west without changing direction. In this case, I will create a line that would be an equator, and it will also be a great circle, the largest possible circle on a sphere. So straight on a sphere means great circle, and that's the term we're going to use from now on when we refer to straight lines on a sphere. Another way to think about straight lines on a sphere is considering the motion, straight motion of a sphere on a straight line that is traced on a plane. So think of this tape representing a straight line on a plane, and if I move my sphere with a straight motion without changing direction, look at the path that is created by this straight tape. Once again, the great circle is the only line we consider straight in a sphere. Any other circle with a smaller radius would not be considered straight. Remember how we created a straight path using an ink drop on a plane? We're going to do the same thing on a sphere and see if the gravity allows an ink drop to create a straight path. Here we go. Notice the path that is created by a drop is again an arc of a great circle. If we were to intersect sphere with a plane through the center of the sphere, the place where sphere and plane will meet will be a great circle, again equivalent of the straight line. Let's look here. Here's our sphere intersected with the plane. Let's look at the place of intersection, and as you can see, the circle that is created is the largest possible circle in a sphere. And if we look at the sphere itself, and it is again a great circle.